Hello everyone! This time I'm going to show how to make a sound voice control webcam to take photo. Something like this. This webcam can work in two modes. The first mode is the sound tracing mode. In this mode, the webcam can rotate based on where the sound comes from. The second mode is voice control mode. In this mode, you can tell the webcam to rotate to some degree and take a photo. So let's see how it works first. Sound control mode. Hi. 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 Then let's see how it works in voice control mode. 22. 171. 'Decrease 91 degree. 'Increase 95 degree. 'Take a photo. Goodbye. Then let's see some details. First, I mount the webcam to the servo through both end nuts. I have two mic modules as the sound sensors. All these components are mounted to the chassis, which is made by a 3D printer. I use Arduino Uno to send a control signal to the servo to make it rotate. A data acquisition device is used to acquire the signal from the two mic modules. Then we will see how different the sound waves are based on different sound source locations. First, if the sound is at A, we can imagine the sound takes less time to reach to the left mic module than the right one. So the purple waveform, which is from the left mic module, is ahead of the yellow one. The yellow one is the sound from the right module. If the sound source is at B, we see there is no time difference. These two waves are almost coincident to each other. If the sound source is at C, the yellow sound wave is ahead of the purple one. So in order to tell where the sound source is, first I used cross-correlation to measure the time difference between the two sound waves, and then I do calibration. Calibration means I put the sound source at different locations on purpose and measure the time difference for each case and record the information. In real application, I just measure the time difference and do the interpolation to extract where the sound source is. In terms of the technique cross-correlation, I found this video has good explanation. You can just watch it there. Then let's take a look at the program. Since the data acquisition device I used is from National Instruments, here I use LabVIEW to do the programming for the sound control mode. Here you can see three graphs showing the sound wave from mic 1, mic 2, and its cross-correlation. These three are just the indicators, you don't need to do anything from them. And here we have a serial port. This serial port is for the Arduino port. Because we use LabVIEW to do the programming and Arduino to send the control signal to the servo. So here we need a connection between LabVIEW and Arduino. So to do that, I use LabVIEW Maker Hub. So here I'm going to show how to do that. So first go to Tools, Maker Hub, Links from where? Wizard. And then you just select your device, and it's Arduino in this case, and it's type, and here is Arduino Uno, and then next. So here, choose the Arduino port, COM3, and then you can click next to follow, and then you can finish this process. Here, as I've loaded the firmware to my Arduino, so I'm not going to finish here. So that's the COM3. And after that process, you can just use the Arduino port as how you use in the Arduino IDE. So here to control the servo, I use channel 9. You can use any channel that is able to send PWM signal. The next line is for the data acquisition configuration. Here I set the sampling frequency as 10,000. It means every 1 second, it acquires 10,000 data from the 2 mic modules. And here I set the number of samples to be 20,000. It means every 2 seconds, it will process the data, and then to see where the sound source is. The count is something I set up here. So the count is to see how many data points within the 20,000 data have amplitude that is above some threshold value, and it's 0.5 volts in this case. And we'll see only when the count is above some value, in this case 100. So if there is 100 data points that have higher amplitude above the threshold, and then the sound source will be considered as a valid sound source, and the servo will turn accordingly. Otherwise, you just take the sound source as some background noise and the servo doesn't turn. So here the sample delay just shows the time difference between the 2 sound waves, as you can see in the previous video. So just stop the program. And here is the user interface, and then we can go to the back panel to see how everything is going to work. Here is the back panel, and we start from here. From this part, it's just some initialization, and it takes the data from the user from the front panel and to start the data flow. And this is the data acquisition device, and after that it will give you the waveform for mic 1, mic 2, and also calculate the cross correlation. That's how you can see in the front panel. And here I did the calibration as I mentioned. So the calibration is here. The numbers in the blue boxes indicate the angle of the servo. So here you can just understand as 500 is 0 degree, 2500 is 180 degree. And at the same time, I just put a sound source at the direction corresponding to the servo. And then I measure the time difference for each case. That's the number in the orange boxes. Here you just don't need to associate any unit to here, because these numbers, the units are dependent on the sampling frequency. So just to consider the relative difference, not the unit. So here within the calibration data here, then when the real time difference comes, we can do the interpolation and to get the servo position here. So for example, if the real time difference is 1.8, and then after the interpolation, it will say the servo position could be 2200, I guess, and then the servo will be turned to that direction. So here, if you want your servo to be more accurate, you can add the calibration points here, but I find 5 points are good enough. So after that, just let the servo turn and avoid servo noise by waiting for 300 microseconds, and then it starts the data processing again. So here I found this is kind of important. Otherwise, when the servo turns, the turning will also have some noise, as you can hear in the video. We don't want this noise to be considered as potential sound source. So set up some time of waiting here that could be helpful. And then just to finish. In voice control mode, I use Python to do the programming, because Python has several speech recognition libraries and it is free. So first, we need to import several packages here. CV2 is for image processing, and here we'll just use that for taking photo. PyFormata is to let Python use Arduino. So by the way, before importing this package, you need to make sure you have loaded the sketch standard formatter to your Arduino. After that, you can use this package to control Arduino. Time has some time-related functions there to use, and we also need the speech recognition library. And then here are just some initializations, and here is the key part. So first, we'll call a microphone. The microphone here is the microphone built in my laptop rather than any of the mic modules I use in the sound control mode. And then it will adjust the ambient noise. When it's ready, it will print say something, and then you can start to say something, and the laptop will just listen to what we are saying. After that, the computer will use the Recognize Google library to recognize what you said in audio and convert that into a voice data message. And the next step is to process the voice data message. First, I will check whether there is a number in the message or not. Also, I will check a keyword increase and decrease. Originally, I tried to use more and less, but I found the recognition is much better if you use increase and decrease. So in the message, if it finds a number and the keyword increase, the computer just increase the degree of the current position by the number here and turn the servo to that position. Also, here the upper limit is 180 degrees. Similarly, if it finds a number and the keyword decrease, it just decreases the degrees of the current position by the number here and turn the servo to that position. And here the lower limit is 0 degree. If there is no keyword increase or decrease but just a number, then just turn the servo to that position. If a photo is in the message, just take the image and just name it and just save it to the folder, and then just let you know by printing a photo was taken. And then you can fetch the image later in the folder, or just show that immediately. That depends on you. And it does that again until it finds goodbye appears in the message, and then just stop and show by printing have a nice day to you. So that's it. And the one thing to mention is that even in the sound control mode, I still use this part to take a photo. That's all about the smart webcam that can be used in sound control mode and voice control mode. Hope you enjoy.